Let's do binary multiplication. Binary multiplication is super straightforward. It's easier than binary subtraction in my opinion because it works exactly like decimal multiplication with zeros and ones. So just recall these basic rules. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. And 1 times 1 is 1. So that should look really familiar to you. Let me show you an example. Suppose we want to multiply 1010 by 101. Okay, so just like we were going to be doing a multiplication problem in decimal, let's stack these up. And I'm going to first multiply this least significant bit on the bottom by everything on the top. So this is 1 times 0 is 0, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. Now at this point I want to move over to the second digit, but first I need to put a little placeholder because I'm going to move to the left here so that all my bits line up correctly. So 0 times 0 is 0, 0 times 1 is 0, 0 times 0 is 0, 0 times 1 is 0. We've got all zeros. Now I want to move to the left to this digit here, and so that means I need to put two placeholders there, and I'm going to multiply this whole thing by 1, which gives me 0, 1, 0, 1. Now at this point I just add straight down. So this is 0, 1 plus 0 is 1, 0, 1 plus 1 is 0, carry the 1, this is 1, and this is 1. So here's my result. I can check this in decimal. In decimal, 1010 is 10, and 101 is 5, so to expect this to be 50. If you put 50 into a decimal to binary converter, you will get 110010, which is indeed what we got using this method for binary multiplication. Okay, good, pretty straightforward. Let's do another example though with floating point numbers. So now suppose we want to multiply 110.011 by 1.101. Okay, so same story as before, we're going to stack these up. This is 110.011 times 1.101. And now I'm going to multiply everything by this first least significant bit on the bottom number. So this gives me 110011. Now I put my x as a placeholder, and then I shift over to the left by 1. These are all zeros. I put another placeholder and I shift to the left again. I multiply everything on top by 1. This gives me 1, 1, 0, 0, 1, 1. Then I put another placeholder, and now I'm ready for this last one here. Multiply everything on top by 1. This gives me 1, 1, 0, 0, 1, 1. Now at this point I'm ready to add straight down everything here. So 1 plus 0 is 1, zeros plus 1 is 1. Here I get 1 plus 1 is 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. And finally, 1 plus 1 is 0, carry the 1. So here's my result, but how do I handle these decimal places? So just like we did in elementary school when we were multiplying decimals, maybe it's been a while since because we use calculators now and computers, but if you recall, what we did is we actually counted the number of digits that were to the right of the decimal place for both of these numbers. So we have 1, 2, 3, 4, 5, 6 digits to the right of the decimal places. So it means I'm going to start over here and I'm going to count over 6. 1, 2, 3, 4, 5, 6. And this is where I place my decimal point. So just remember, this works the same as decimal. You count the number of digits to the right of the decimal place, add those up, and then start at the right and move to the left by that many places, and that's where you place your decimal if you're doing a floating point binary multiplication.